So atmospheric air is approximately 78% nitrogen, 21% oxygen, and then really around 1% or less of carbon dioxide, depending on who you read, and then other gases here. The nitrogen does not absorb into the lungs unless you have massive pressure on the thoracic wall. And the only time that is ever seen is in diving. As you go down underwater and you dive, after you hit 33 feet, you have twice the pressure on the lungs as you do at sea level. So we call the atmosphere of the pressure at sea level 1 atmosphere, measured by what's called millimeters of mercury, or 760 millimeters of mercury. So as we go down underwater and we go below 33 feet, we begin to need more pressure on the piece that goes into the mouth, and it forces more air in, but then that diffuses nitrogen into the bloodstream. So nitrogen, let me move this down for you a little bit here. Forgive me here. Nitrogen begins to diffuse into the bloodstream. So when you come back up towards sea level, you have to go slowly to let the nitrogen reabsorb out into the lungs and out the mouth. If not, you could get an embolism, an air pocket in a blood vessel, and get a stroke. Or you could get an air pocket in the in a joint called the bends. That is very crippling. So how is oxygen carried in the lungs? Inside a red blood cell, it is full of a chemical called hemoglobin. So heme, H-E-M-E, is actually iron. And every hemoglobin has 4 irons in its molecule. So this is a hemoglobin molecule. Globin is a protein. So we have an iron, heme, globin protein complex. Iron has an affinity for oxygen. Oxygen likes to stick to iron. Oxygen is also what causes iron to rust. So, for every hemoglobin molecule, we have 4 hemes or irons, and each of those carries 1 oxygen. So, red blood cells are full of hemoglobin. Approximately 97% of all oxygen is transported in the blood on the heme portion of the hemoglobin, and then 3% is simply dissolved inside the plasma fluid. Carbon dioxide is different. It does not get carried on the heme portion of the hemoglobin, but gets carried in the globin portion, or the protein itself. So this portion here, outside of the iron, can carry approximately 23% of the carbon dioxide. Maybe approximately 7% is dissolved in the plasma, but nearly 70% does something different. It actually gets converted to an acid, or carbonic acid. So carbon dioxide gets converted to carbonic acid in the blood. This is the acidity of your blood. This number says 60%, but it's probably closer to 70%. So here's a very important point. Generally speaking, our breathing is regulated not by our oxygen concentration in our bloodstream, but it is our carbon dioxide concentration in our bloodstream. So when we hold our breath, we are not breathing out carbon dioxide. Because we are not breathing it out, the carbonic acid, which is now carbon dioxide is being stored as carbonic acid, is building up. We are beginning to acidify the blood. that is measured in the brain at the hypothalamus, and we alter our breathing or attempt to breathe to blow that back out of our lungs. All of you have probably heard of carbon monoxide. Carbon monoxide is colorless, odorless, and tasteless. However, carbon monoxide has an affinity for iron greater than oxygen. When we bind carbon monoxide into the heme, so if you are running a generator and this exhaust gets into the house, if your furnace is leaking, you will actually bind up all the iron with carbon monoxide and can get no oxygen. You will suffocate and die. But you are not aware of it because the brain is measuring carbon dioxide. It's measuring CO2 as the carbonic acid. It is not measuring your oxygen levels. Therefore, you are under no distress because your carbon dioxide is not being affected. Carbon dioxide is not carried on the iron. So carbon monoxide poisoning is very dangerous because you are unaware that it is happening. Everyone should absolutely have a carbon monoxide tester in your home if you have any combustible heat in your house. Also, we have something called tidal breathing. So this is what breathing looks like on a graph. This is a deep inhalation, that is an exhalation, but our normal quiet breathing is called tidal volume. So this middle section here is called tidal volume.